Let us talk about the Caesar cipher. What's going on with this? What is it? It is an ancient, simple form of encryption used by Julius Caesar to encrypt military communication. So I have no idea how they passed notes back in the day on stone tablets or whatnot. Whatever it is, if it was intercepted, the other side's going to know what you're doing. You know, your plans or whatever. So came up with a way of scrambling the communication so it just looked like a garbled junk and like, what the hell is this? They didn't have your Intel Core i5 to break the cipher, so they were stuck if they couldn't figure out the pattern. I think you could probably break this by sort of figuring out the pattern, but encryption wasn't much of a thing back in the day, so they didn't have the resources, so it worked for them. So how it works specifically is you take the letters that you start with in plain text, and you're going to shift them forward or backwards in the alphabet by a designated amount called a shift or a key. This is really how it works. Basically, you start with your plain text, your actual message, and then you designate some constant value, positive or negative, to move each letter forward or backwards in the alphabet. And here's a little idea where it's like, let's say you have the letter B, and then you have a shift of 2. You move B 2 letters forward in the alphabet. So then that's going to become B, C, D. So it's kind of a D. So B encrypted in this scenario becomes a D. You do that for every single letter of your message. And then you have an encrypted message. It's not going to look like the original, and many times the more you shift it, the more obscured that the original message is. If you think about this a little bit, it is pretty easy to break. You could really almost break it using pen and paper, but like very easy to break using computers, because you just try all the combinations and you can break it with a brute force attack, which is really what that is. Brute force is just fire all the bullets, try everything, and then see what you can do with code is you can try all the possible shifts of an encrypted message, and then look for the one that actually has readable text in the outcome. That's the one that's going to be the real message. There's not really going to be more than one, so it is very easy to break. So you're not really going to use it for real encryption. It's more for educational purposes, like the setting we're in right now, where you got some jackass trying to tell it to you. I'm not the jackass. Those other guys, not me. Anyway, it's really just for practice. It's kind of like one of those kind of coding journeys where, like, in your coding journey, you're going to do Caesar cipher stuff on the way to becoming a better programmer. But it is good to study, because it's a basic process in encryption and kind of gets you ready for real encryption scenarios, because you go through the simple pieces. It is kind of like baby steps for getting into encryption. It may be the simplest form of encryption. I'm not really in that arena, so I don't know like the progression, but I do know this one. Let's look at an example now, specifically of using this. Given the word hello, let's go ahead and encrypt this by shifting it 10 spaces. And how it's going to work is we're going to take each letter and move it forward 10 spaces in the alphabet. So here's a little visual. to break it down, you can simply look at the alphabet in order. Hopefully I didn't miss any letters here. But you look at where H is, and the guideline is to shift forward by 10 spaces. You literally just count 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It lands on R. And you see here index-wise, like order-wise, it's going from index 7 to index 17, of course 10 spaces. So an H becomes an R. Magic. Let's look at another piece here. If you look at the next letter, the letter E, so we know that the letter H is going to be R. The letter E, this is index 4, 0, 1, 2, 3, 4. Shifted forward by 10, of course, 14. It gives you the O. So E becomes O. So we got our first two letters of our encryption. HE becomes RO. This is how the Caesar cipher works, and your shift can be forwards or backwards. You can do a shift by -10 to go backwards. So going along with this idea, here is your complete result. Hello, shifted by 10 is, and this is encrypted text, so it's not a real word. So, you know, I can pronounce it, but that would be just silly, right? You can pronounce it wherever you are and have fun with that. This is how Caesar cipher works. And next, I'm going to get into the algorithmic approach that I'm going to use to tackle this project. Now I'm going to give you a few points on my approach to this project. First things first, I'm going to type out the alphabet to use as a chart for shifting. I'm going to put the entire alphabet sequentially into a string. The shifting relies on the order of the alphabet, so why not use the alphabet as a guide where as I go and look at each letter, I can index into the alphabet and then shift forwards or backwards based on the index. So you get a letter, you look up the index, and then you will shift forward or backwards, really adding to or subtracting from the index to shift to the other encrypted letter, as it were. It'll look something like this. Taking a look at this sucker, and it's really going to look like this, where it's a continuous string sequential alphabet. And let's say we're going to, let's say we start with the letter B, and you know that's index 1, and you want to shift forward whatever, let's say 3, you shift forward 3, 1, 2, 3, and then it'll be, you know, index 4, which is E. So B shifted to E. Programmatically, you're gonna get the index of B. You're gonna add your shift of 3, and then that index, which is index 4, is gonna be E. So you've shifted, and you can use this for forward or backward shifting. But we're gonna employ a string sequential alphabet to facilitate the shifting. There's other ways to do it. I feel like this is the easiest to understand, so I'm going with it. The uppercase letters are going to be handled by converting that alphabet string to uppercase. You saw the alphabet string, and I'll show it again. It's in lowercase. So when I encounter uppercase letters, of course, you can't look up an uppercase letter in that string if it's not there. So I'm going to convert that string to uppercase and then do my thing via the Python upper function. It'll be very easy. The non-alphabetic or non-alphabetical, as it were, non-letter characters are going to be ignored and passed along as is or as are. I'm not sure the correct way to say it, but it doesn't matter. Yeah, only dealing with encrypting and decrypting letters in this mother. The encryption and decryption are actually going to be accomplished in the same function. I'm going for a one function solution, folks. And this is going to be possible because of the keyword argument functionality in Python, where I'm going to use a Boolean keyword argument where I'll just toggle it true or false depending on if I'm encrypting or decrypting. The processes or the code is so similar to encrypt and decrypt. It's really just the difference of a character. So why not just use the same function to do both of them? And you'll see in the code. Last point here is that the modulo operation is going to be employed to handle wraparound. Those of you familiar with Cipher understand wraparound a little bit, but for those who are not that familiar, get familiar. But what wraparound is when you have a shift that takes you off the end of the alphabet, basically, how do you handle restarting at the beginning of the alphabet for the rest of the shifting? Go back to our alphabet string. Let's think about a case where we got a W and you got a shift of 15. Where, of course, it's going to take you past the Z and then, way out here into the netherworld. Well, your result needs to be a letter, so it's got to shift around or wrap around and continue with the alphabet. Like a shift of 15 is going to be like W, it'll be 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it might be the L if I counted correctly, but how do you handle that programmatically? You start with the index of the W, which I think is 25, 24, 23, 22, 22. What? That's like a 3. 22. And then I was talking about a shift of 15. Let's do that math real quick. It's 7, 3. 37, of course, that's going to take you past the Z. We're going to use modulo to do the wraparound, where we're going to do modulo 26 actually, and that's going to guarantee the number is going to be in the range of 0 to 25, and that's within the valid range of indexes of our string, so it's going to be safe, so to speak. So let's look at 37 modulo 25, which is what we've got, 26, which is what we've got to do to do our wraparound effectively. And I'm going to employ, because I don't want to do that. See if I can bring it back. Nope, ain't going to bring it back. Oh well. Screwed that up. But anyway, 37 mod 26. This is going to be the number that we end on, or the index that we end on. Remember, the one we're highlighting is W, which is 22. And then plus 15 is 37. Nice reset there. Nice save, right? Good stuff. Okay. I'm going to use the Windows calculator to do this modulo, because I don't know it by, in my head, whatever. So 37 modulo 26, 11. So it's index 11. I centered on L as the destination. So let's look at it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that is L. So that's it. And that is how you handle wraparound with modulo. That's what I mean. You'll see another example in the code itself. as I explained there, but this is what I mean by using modulo for wraparound. And next, we're going to look at the actual code so you can see what's going on inside of this project. Good times. Talk to you soon. It is time to check out the code for the Cipher Cipher. Cipher Cipher function, yes. I was thinking of a tongue twister, that's why I paused for a second. Anyway, let's look at this code. As I said before, I'm doing this in a single function, encryption and decryption. And the parameters are going to be what you're encrypting, the text, the shift, either forwards or backwards. This is the number of places to go forwards or backwards in the alphabet. And then I have a keyword argument, encrypt, that is going to say, are we doing encryption or decryption? So if this is true, the text is going to be encrypted. If it's false, the text is going to be decrypted. With this keyword argument, the default is going to be true. So you can, the argument is optional. So if I don't include it, it's going to be a true. And then if I do include the third argument, it can either be true or false. Got it, good. So I begin by creating an empty string that is going to either hold the encrypted or decrypted text. It's going to hold whatever the result is. I just decided to call it encrypted, but it may hold the decrypted if we are decrypting in this instance. Whatever the result is, it is going to hold it. Line 6, I begin looping. I'm looping through the string of text one, or the text string, whatever you call it, one character at a time, because I'm going to encrypt it one character at a time or not. First test is it a letter? If it's a letter, I'm going to do the encryption. If it's not a letter, I'm not doing anything to it. So numbers, other special characters, spaces, they're just going to be passed through. I'm only concerned with letters in this case. So if it is a letter, and then I have to change or have to develop special case for uppercase, lowercase, because my alphabet is lowercase by default. So if I want to move through this alphabet properly, it's got to have the proper case. So if I encounter uppercase letters, I'm going to convert my alphabet to uppercase and then do the damn thing. So if this is an uppercase letter, I'm changing my alphabet to uppercase and then proceeding. So once I change the alphabet to uppercase, then there's more testing. So I have if encrypt, meaning if I'm encrypting in this scenario, I'm going to do one thing. The else would be for decrypting. If I'm encrypting this letter, then I'm going to do this one. And this is, of course, the actual encryption. So how it's going to work, or actually it's the pre sort of encryption. So I'm going to find the index of the current letter in the alphabet, and then I'm going to apply the shift. So like if the shift is the letter S and then, or no, if the letter is the letter S and then I have to shift, I'm going to shift it 10 places forward, wherever that may be. And then you have modulo 26. This is important. The modulo 26 handles overflow. So if you have a letter plus a shift that goes off the end, if it goes past Z, the modulo 26 is gonna do the overflow. Wrap it around and continue with the next letter. So like a Z plus 1 is going to be an A. so it does the wraparound. So the modulo 26, it will handle a shift of any size. If you have a shift of 600 and it wraps around, I guess virtually, bunches of times. Really, what the modulo does, it's going to take whatever the index plus the shift is, and it's going to convert it to the range of 0 to 25, so that it's going to fit. It's going to have a valid index in the alphabet. That's really what modulo does there. So any shift is good there. And that's going to encrypt one letter. And then the else would be for decrypt. And decrypt is the same as encrypt, other than it's minus. And this will work for positive or negative shifts. It's just, obviously for it'll do the opposite of the shifting. So like if your encrypt is forward 10 places, your decrypt is going to be backwards 10 places. Pretty easy to understand stuff. And the minus is going to handle that. You have mod 26 once again, because you want to be able to handle shifts that take you beyond the end of the alphabet. Then with this if here, this is going to, as the comment says, it's going to handle results less than 0 from a negative shift. So if you have a negative shift, I guess potentially in either of these scenarios, if you have a negative shift, it is going to, many times it's going to take you into the negative. Like, let's say you end up with a negative 35 as a result of some large negative shift. It's going to add 26 to it. But actually, you won't end up with negative 35 because of the modulo. So because of the modulo, your negative number, I think the max negative would be, a magnitude would be 25. But whatever it is, it's you can't index with a negative number here, of course, and have it be correct. So what's going to happen is 26 is going to be added to it to put it into this quality range, and it ends up working out properly. So like if you, let's look at an example, sort of. We have to do it. Let's think about the letter F up there, and let's do a negative shift to it. The letter F, that is 0, 1, 2, 3, 4, 5. This is index 5 here. Let's say our shift is negative 12 from 5. So then we have, in this case, it's going to be, well, really either of these. It'll be 5 minus 12, which is a negative 7. Of course, a negative 7 is back here. It takes you off the edge. So then you do a negative 7 plus 26. And that's going to give you 19, which is, let's see, 0, 1, 2, 3, 4, 5, 6. I think it's a T. I think 19 is T. There's your plus 26. So let's actually do it, and let's wrap around and see if that's correct. If you have F and then you go 12 places back and wrap around, it should end up at T. Let's do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it does. So negative 12 is T, that is right, and it's brought to you by the fact that the negative 12 is, no, actually, the negative 7, which is the result, is less than 0. Then you add 26 to that, and it puts you at the 19. And it's the same result if we count backwards and wrap around. So there's confirmation that that works. Hopefully you followed that. I barely did. But anyway, we move on. So that's that. And then once you're done with the shifting, you concatenate. You index in using your new shifted index. This is the shifted index. You index in, concatenate it, and that letter is either encrypted or decrypted, depending on what you're doing. Then we got an else for this if. The else is going to be if this is lowercase down here. This handles your lowercase scenario. So, and notice I am not doing a conversion because the alphabet's already lowercase, but the logic is the same. Plus shift mod 26 for encryption, minus shift mod 26 for decryption. This handles our negative outcome, and then we concatenate. This else is for an if that's up here. This else would be if we have a situation where this is for non-letters. And that's what that's for. So we handle letters up here, non-letters, and we are encrypted, folks, or decrypted. And once we do that, we return it, and we're good. So let us test this sucker out. We've got text to encrypt, and we're going to do a shift of 35, just making it way past, and the mod 26 will be employed. So let us check it out. All right, so we got some text here, but what the hell is this? Yeah, I could go ahead and count forward and see what it is, but there are websites out there where we can test our work. So I'm gonna bring one of these in, baby. Let's go. So what we got here is hello Jerry shifted 35. So yeah, with this one you can put in your plain text, your shift, and then you see what the output is. So my input is here. Hello, Jerry. Actually saw Jerry Seinfeld a couple of days ago, so very interesting. I'm sure he rarely comes to Maine. So the shift is going to be 35, and he actually did the hello Newman on stage. Good stuff. So hello, Jerry shifted 35. That looks like it's correct. Dope. All right, so that works. Now I'm going to do the decryption side for that test. So I'm just going to decrypt the same text here. So let me grab it. I'm going to throw it in a variable. Put it in a variable. Of course, got to make it a string. And I'm going to plug it in here. Keep my shift of 35 because if you're going to decrypt, it's got to be consistent to what you're encrypted with. And then I have to change the third argument to false because I am not encrypting, I'm decrypting. So encrypt will be false. And when I run this, this should say hello Jerry. All right, Ali oxen free. That's it, folks. So the decrypt works, the encrypt works, all good. Hello, Jerry. All right, folks. That is a look at Caesar Cipher, the code, and that is that.